Hi, my name is Daniel Gross, and this is going to be my DSE 503 final project on the San Diego home price versus household income growth rate analysis. So today I'll be taking you through my project background, its datasets and features, the methods I applied, as well as the experiments and discussion, and then my conclusions and future work. Okay, so let's get into a little bit of the project background. So my topic selection is somewhat personal to me because my wife and I have been actively exploring homes in the San Diego area, and we have noticed that over the past few years the average price for a typical single family home has increased significantly. As house prices continue to rise to record highs, a common discussion point amongst my peers is the decreasing affordability of housing in the San Diego County area. The question of affordability is complex and does require an analysis of all household expenses longitudinally to fully answer, but a more accessible proxy is to compare the changes in median house price and median household income to determine if income is increasing at the same rate as house prices. I thought that by taking the time to empirically explore both of these trends, I would get a better understanding if San Diego is in fact becoming less affordable. So to summarize, my project objective for this analysis is actually twofold. First, I wanted to answer the question, are median household income and median home price growing at equal rates, or is there a significant disparity? Also, I wanted to know that given the longitudinal data over the last 20 years that I was able to gather, what predictions can be made regarding future home prices and income trends? Essentially, if I were to wait until I was in a better financial position to buy a house, are the home prices going to outpace my salary? With those questions in mind, let's take a look at the dataset and its features. I located the primary data for my analysis from two sources. The data for median house price was sourced from Zillow Research Data, and the data for median household income was sourced from the Federal Reserve of St. Louis, or the Fred. The data CSVs were downloaded and stored in my Google Drive cloud storage prior to ingestion into Google Colab. The data scope initially did vary to some extent before it was cleaned. Median house price data was obtained from Zillow Research, as I just stated, and encompassed monthly median sale prices for a single family home across U.S. counties from the year 2000 to the year 2024. For the purpose of the study, we filtered the dataset to include records specifically relevant to San Diego County with any non-pertinent location descriptors removed. So you can see some of those descriptor columns in the screenshot to the right, such as state, metro, and size rank. The median household income data was sourced from the Fred website, and this provided an annual median household income value for San Diego County, spanning from the years 1989 to 2022, with certain gaps, as you see in the screenshot to the right. The aggregated dataset at the end of this was structured to include the time period 2000 to 2022, the overlap of both datasets, focusing exclusively on the median values reported by both datasets. So we did not include any additional variables, and our study is centered solely around examining the relationship between those two numerical series, the median house price and the median household income. To give you a more clear picture as to how the data was aggregated, prior to any visualization or analysis, the two datasets were cleaned and transformed to enable this aggregation into a single data frame. We can see the cleaned median price data frame on the left, the median income data frame in the middle, and then the aggregated data frame output to the right. With that data background in mind, let's get into some of the methods that I applied. So I used a variety of Python libraries in this analysis. I applied analytical methods involving a combination of PySpark, Pandas, and NumPy libraries to ingest, reshape, restrict, and process the data. The majority of the program is based in Pandas and Matplotlib because they were the most applicable to what I was trying to achieve, and I found those libraries a little bit easier to work with than PySpark. But I did try to leverage what we've learned in PySpark throughout the program within this analysis as well. I should note that there was a component of additional measure calculation within my program. In addition to the raw income and house price values, it was critical to calculate the percentage change year to year. So those series were added to the main data frame. As you see, those are the three rightmost columns within the table pictured there. I am showing the percentage changes in full percentage points. The median price change is the change year over year. The median income change is the change in median household income year over year. And then the change comparison is simply the difference between those two columns. So where you see a positive value in change comparison, that would mean that the median house price change exceeded the median income change in terms of a relative percentage increase. Additionally, because we have no data for 1999, you'll notice that those change columns do not have a value in index 0, so the year 2000, because we have nothing to compare it to. The basic data collection, ingestion, cleaning, and aggregation steps out of the way, I chose to visualize the basic values in a few different ways to better understand subjectively what the trends looked like. You can see in this first line chart here, I'm showing the median value trend. So this is not the percentage change, this is the raw dollar value change over time. You can see that from 2000 to 2022, the median home price, so the blue line pictured there, has a much more varied and significant slope over time, while the median income maintains a more consistent, more gradual slope over time. Now, if I took this at face value, it would look like the median home price is far and away greatly exceeding the increase in median household income. But because the starting point for the median home price is so much higher than the median household income, the raw dollar value increases is not representative of how much it is increasing proportionally, which is why the second way that I chose to visualize this data was by visualizing those changes year over year that we calculated earlier. So again, the median home price percentage change per year is visualized in blue, and the median household income change per year is visualized in orange. So, similar to what we saw in the previous chart, the median household income rate of change per year is more consistent, although here you can see more variation. But the real story in this chart is the median home price change. You can see that pre-2005 it was the highest it has been within the scope of my data set. But then it experiences a very significant dip into negative percentage points, meaning that the values for those years from 2006 to roughly 2010 were less than the prior year. And what we're seeing there is the impact of the Great Recession, obviously. It has recovered, and from 2010 to 2015, or I guess about 2013, there was a spike in investors purchasing up those cheap homes and the values increasing to a certain extent, but then it did start to level out until a little bit after 2020, which is the COVID spike, but you can see that by 2022 it was also leveling out, and I expect through 2024, if we were to expand that median price change, we would see it relatively consistent, as well as the interest rates have remained substantially higher than they were during the COVID stimulation period. Based on this chart subjectively, it still seems like the median home price change will typically outpace the median household income change, excluding anomalies like the housing bubble bursting. So one other way that I chose to visualize this data initially, just to get a better understanding, was by mapping the house price rate of change versus the household income rate of change. So what we see in this scatter plot here is we see the median price change in full percentage points mapped on the y-axis, and we see the median income change in full percentage points mapped on the x-axis. So any of the points colored in red are years in which the home price increase rate outpaced the income increase rate. So that was 14 of the 22 years included here. And then all of the green points are years when the home price increase rate fell below the income increase rate, and that was 8 years. So as a consumer, I'm looking for those green dots, those years when my relative household income would have increased more relative to the price of the average median home. However, in this case, note that anecdotally, 14 of 22 years, so the majority were red. So more often than not, in my sample size, the home price rate was outpacing income. With this initial data exploration out of the way, let's get into something a little bit more concrete. Now we'll be talking about experiments, results, and discussion. The first method that I applied to check if there was a statistically significant difference between these two rates was a paired t-test. This paired t-test checked the average median income change versus the average median price change and found ultimately not a significant difference. Let's get into the details. So the average median income change, excluding that NAA value, was 3.33. For the median price change, we got an average of 6.77. So at least they're both increasing over time. This yielded a t-test statistic of negative 1.66 with a p-value of 0.11. So delving into the meaning behind those statistics, the negative t statistic indicated that on average, the median income change tended to be lower than the median price change, which is what I hypothesized. However, that difference was not found to be statistically significant at the standard alpha level of 0.05, as evidenced by that p-value of 0.11. Due to this result, I fail to reject the null hypothesis, suggesting that there is no conclusive evidence of a significant difference between the average values of median income and median price change within the tested sample. I have to say here that I think this is more an issue of my sample size being too small to find a significant result, because you can see the difference in the median price changes is significant enough, and the p-value is approaching that 0.05 significance level. So I think if I had doubled my sample size to 40 years, that I would certainly have a significant test. I would have found a significant test result at that alpha level of 0.05. Nonetheless, in this case, I did not find a significant difference, so I moved on to my second modeling technique, the linear regression model. First linear regression exercise was based on the median income percentage change, and my second linear regression model, which I'll get to in a second, is the raw dollar value. Starting off with the percentage change, I wanted to try the 80% train, 20% test method before just training the regression on the entire dataset to predict future values. So I did that here in the chart that you're seeing. I will say that this did not yield particularly useful results. You can see that the R-squared value of negative 0.07 indicates that this is essentially worse than a flat line of the average of all of the data points. I looked into this, and I really think it's a result of the random sampling selection. So what I mean by that is you can see based on the linear regression, the line basically follows the training data, those blue data points. However, the selected test data points don't follow that trend. So we're predicting a slope coefficient of 0.12, so a very gradual positive increase. However, we can see our rightmost points, so the points with the highest median price change that we are testing against are actually lower than these 2 points here. So that would indicate a negative slope, not a positive slope. So you can see that it directly disagrees with the linear regression model produced from the training data. So this exercise was good practice for training and testing data, but was not particularly useful to answering any of my questions. With that being said, I moved on to just generate a linear regression model based off of 100% of the data, and I got a intercept of 2.38, a slope of 14, so similar to what I got off of the training data, a p-value of 0.04, and a r value of 0.44. These results mean in the context of our investigation. Essentially, the intercept of 2.38% is the baseline change in household income when housing prices remain unchanged, so assuming they had zero growth for the year. The slope of 0.14 indicates that every 1% increase in housing prices correlates to a household income increase by 0.14, so there's a positive association between those two variables, but we can see that incomes are expected to grow much more slowly than housing prices. The p-value of 0.04 is significantly below the 0.05 alpha level threshold, so there is strong evidence to reject the null hypothesis of no relationship between those two changes, so we can definitely say that they are correlated in a meaningful way. The correlation coefficient, however, suggests a moderate positive correlation, implying that as housing prices increase, household incomes tend to increase proportionally, although there are other factors influencing incomes. As we can see, 0.44 is meaningful, but it is not a strong correlation coefficient, I would say. It's not above 70. It's certainly not above 0.9. So overall, these findings underscore a statistically significant and positive relationship between housing price changes and household income changes, which does highlight implications for housing policy and economic analysis. So basically, we do see that they are related and require further investigation into how they are interrelated. With this linear regression of the rate changes over time completed, I also wanted to take a look at the value-based linear regression model. And as you can see here, based off of my training and testing exercise, this worked a lot more cleanly just based on how the values are expected to increase over time in a very linear format. So again, executing the exact same exercise, we had a intercept of 25,571.22. We had a slope coefficient of 0.08, mean squared error of roughly 34 million, and a r-squared value of 0.87. So we can interpret this to mean there is a strong correlation coefficient, so the median price increase is definitely tied to the median income increase. There is a fair amount of error, so the data points are not directly on that linear regression line, but it is relatively tight. The slope is positive, but low, so the as the median price increases, the median income is increasing 8% roughly proportionally to the median price. So for every 1%, for every $1 the median price increases, we would expect median income to increase by 8 cents. So still just a fraction of the increase is what we're seeing there. And then the intercept of roughly 25,000 is just what we would expect our income to be if home prices were zero, which they never will be. So not too relevant in this case. Okay, moving on to my 100% trained model. We see very similar statistics, slightly lower intercept, the same slope of 0.8, a very significant p-value of 0.00, so we know these are 100% related. Most definitely the increases in median home price are tied to the increases in median income. And we got an R value of 0.9, so also a very strong correlation. So what does this tell us? The slope of 0.08 indicates that for every 1 unit increase in median home price, median household income is expected to increase by 0.08 units, so dollars. The positive slope underscores a direct association between rising home prices and higher household incomes. So as house prices increase, we tend to see incomes increase as well. The p-value of effectively 0 is well below the conventional alpha level of 0.05, which does provide strong evidence rejecting the null hypothesis that there is no relationship between the two variables. So based on the chart, you can clearly see that there is a relationship between the two variables. The correlation coefficient of 0.9 does indicate a strong positive linear relationship between the median home price and household incomes, which suggests that as home prices rise, incomes tend to increase proportionally, although not perfectly, as we talked about a little bit earlier. And overall, these findings highlight a robust, statistically significant positive association between those two series that we discussed, which we would expect to see in this time series data. So nothing super surprising there in the dollar-based linear regression model, but we did see a clear relationship. Given the well-defined relationship, I thought it would be a good idea to take that linear regression line and project it out to a set median home price of $2 million. We're not there yet, but I know we will get there eventually. So I wanted to see proportionally what we would expect our median income to look like at that point once homes reach that astronomical average price. So currently, given the linear regression model that I've created, it looks like I can expect a median household income of roughly $190,000 per year by the time that we see the median home prices hit $2 million. What's interesting about this is that I know in the year 2024, so not included in this data set, we are hovering around a median home price of a little less than $1 million, and our median income is roughly $95,000. So you can see that extrapolating out to that 2 million price point at a household income of 190, we are not like the ratio between the median income and the median home price is not that significantly impacted, even though the slope of this linear regression is only, 8% or 0.14%. So that is somewhat promising. In the exercise that I realized I needed to calculate the median home price and the median household income over time so I could see in a number of years what I expected these values to be rather than just the relationship between the two series. So I decided to conduct a ARIMA model. I started off again training and testing just to evaluate the efficacy of this modeling exercise. You can see here I'm testing based on the median home price. So you can see that it used 80% of the data through the index 17 and then tested through for index 18 through 22, where it's forecasting the median price as well as the median income for the values 600 through 617 and then 77 through 84. I then compared that to the actual values for those home prices, and you can see the actual value really took off at index 20 year 2020 because of COVID. So it was not predictable based on the historic data that I uploaded. So I can't really fault the ARIMA model in this case. It's just a unexpected trend. Who would have seen COVID coming? But because of that unexpected upturn, the evaluation for this model is not particularly favorable. The mean squared error is in the billions for median price. It's in the millions for median income, and then the root mean squared error is 157,000 approximately, and the root mean squared error for median income is roughly 8,000. So not particularly accurate given the upturn. Using this 80% training, 20% test format. Here you can see the same results just with the visualization of median income. So the predicted values still lag behind the actual values to a certain extent, but the variation is much less significant, partially because our salaries did not get a disproportionate increase, even though home prices and everything else got a disproportionate increase. But I thought that this was a insightful comparison. So if we look at this chart, you can see the home prices versus the income chart. It's just no comparison. Anyway, moving on, I trained the ARIMA model on 100% of the data and produced the chart you see below. So these are the actual and forecasted median house prices and median household income values for the highlighted sections on the right side of the graph. You can see that those are just forecasted values, and then the actuals are the more variable lines up until that point without the highlighted section. So you can see that the forecast follows the overall trend of the actuals as you would expect, because they're based on the actuals. On this chart, it does seem that the median home price is clearly outpacing the median income through the year 2035. But again, because we're dealing with a larger value, we need to be considering the rate of increase or the percentage change. So I chose to calculate the ratio between the median income change and then the median price change. Represents the percentage point increase in the projected median price. So it's just calculating how much the ARIMA model is projecting that the median price will increase year over year. Median income change is doing the exact same thing for the median income column forecast. And then the income to price ratio is the median income forecast value compared to the median price value. So I would say that the income price ratio is the most direct measure we have to affordability because it is setting your median income against the median home price value. So you're saying in the year 2023 that our median income is 10% of the median home price value, but in the year 2035 it's dropped to 8.37%, meaning that our projected median income is going to be a smaller and smaller amount relative to the cost of a single family home, representing a decrease in affordability. So in closing, let's revisit those two questions that I posed at the beginning of this presentation. Are median household income and median home prices growing at equal rates, or is there a significant disparity? Based on my linear regression modeling and my ARIMA modeling, I can conclusively say that median home prices are growing at a faster rate, or a rate that outpaces median household income growth. Carrying that into the second question, we can predict that the median household income is going to become a smaller and smaller percentage of the median home price, which represents a decrease in affordability specific to the San Diego, California area. Given this, my takeaway is that I need to get into the real estate market or the home ownership market as soon as possible, as soon as I can, so that I can maintain a acceptable income to home value ratio, so that as my home increases in value, I'm building equity, not taking on more debt if I were to delay my purchase. I hope that this project was interesting and that it could be easily applied to other areas if it's something that that interests you. And yeah, I appreciate you taking the time to listen to me today.